All right, now we are going to increase the level of difficulty in working with inverse trig function integration by involving the process of completing the square, which you learned back in Algebra 2 when solving a quadratic or putting a quadratic in vertex form, or even if you studied conics, putting conics into vertex form. So basically, if I want to find the general antiderivative of 1 divided by x squared plus 6x plus 25, I actually have no idea how to do this. This is not factorable, so I cannot use partial fraction decomposition. But since I have an x squared plus a value, I'm hoping I can somehow manipulate this into an arctan situation. So problem is I can't factor out the x here because I've got a 6x term, which complicates my life here. So what I'm going to do is I need to complete the square just in the denominator. So recall that completing the square means to take the constant and kind of put it outside parentheses and just look at the first two terms with the x variables in them. So x squared plus 6x plus something is equal to, or plus 25 outside the paren, and then of course I have to subtract that something so I maintain equality. So whatever number this is, I add it here and subtract it here. Well, what number do we need to add and subtract? Well, recall that you always work with b over 2 and you square it when working to complete the square on a quadratic. And that is when you have a standard form of a quadratic, ax squared plus bx plus c, so that your b value is the constant in front of x. So in this case, we have 6 divided by 2, which is 3. We square it to get 9. So 9 is the number that we are going to both add here and subtract here. So what that means for us is, since we have x squared plus 6x plus 9 in paren, that simplifies to the square of a binomial x plus 3 quantity squared, and the 25 minus 9 goes to 16. So we put this back into our integral, and so the integrand is now 1 divided by x plus 3 all squared plus 16. And now we can take the same approach we took when we just had an x squared instead of an x plus 3 squared. And that is, we're going to factor out a 16 out in front of our integral sign, of course keeping that 16 in the denominator. So what happens is that we end up having to divide both of these terms by 16 when we put this 1/16 out in front here. So x plus 3 squared over 16 can be rewritten as x plus 3 over 4 all squared, because conveniently 16 is a perfect square. So now you're going to use u substitution with your u value of x plus 3 over 4. That's right here. And then when I differentiate, du equals 1/4 dx. So I now have to multiply by 4 to get 4 du equals dx, and then I substitute. So the 4 goes out in front of this 1/16 to give me 1/4. And then for the x plus 3 over 4, I sub in a u. So now I have a fairly standard problem using arctan, because 1 over u squared plus 1 integrates to arctan of u, and I have a constant of 1/4 out in front. And we do a final substitution for u, which of course was x plus 3 over 4. And we have our final answer of 1/4 arctan of x plus 3 over 4 plus c. So let's do a practice problem with arcsine. So here we want the general antiderivative of 1 over the square root of negative x squared minus 6x plus 7. So I know that this has to be arcsine because, of course, arcsine in the denominator has the square root of 1 minus x squared. So the square root in the denominator and the negative x squared tells us to work with arcsine. So to complete the square, I care about this expression underneath the radical. So I'm leaving a 7 out in front, and then I'm going to subtract a whole parentheses here, and I've basically had to factor a negative out of each of these two terms. That's important because the only coefficient in front of x squared that you may have when completing the square is a 1. So I had to factor out that negative 1. So now I have x squared plus 6x, and I need to know b over 2 squared. b is 6, 6 over 2 is 3, and I'm adding a 9 here, and I'm actually, do you see how I'm subtracting a 9? When I added a 9 here, it's negative 9. And so I add a 9 out in front. So I have 9 minus 9 to maintain equality. So that gets me to 16 minus, and then in paren I have x plus 3 all squared. So if I put this, actually one more thing I'm going to do is I'm going to factor out a 16 here to have 16 times 1 minus x plus 3 all squared over 16, which of course gives me 16 times, let me rewrite this, 16 times 1 minus x plus 3 over 4 all squared. This then goes underneath my radical in the denominator. So what I'm going to have when I rewrite this is my denominator here. So out in front I get a 1 over 16, and then I have a 1 divided by, and in the square root I have 1 minus x plus 3 over 4 all squared, and of course a dx. So now it's time to revert to u substitution. And when I use u substitution, I'm going to call my u x plus 3 over 4. And of course my du will then be 1/4 dx, and I do have to multiply by 4 to isolate my dx. So I have 4 du equals dx. And when I sub in, I multiply the 1/16 out in front by a 4 to get 1/4 in front. And then under the radical, I substitute in my u value, so I have 1 minus u squared and a du out here. This then is going to integrate to 1/4 arc sine of u plus c, and then I can just resub in for my u to get my final answer of 1/4 arc sine of x plus 3 over 4 plus c. Now I have 2 more problems to practice on here, and I will conveniently separate out my work. I think there might be a typo on this first problem. This should be a 2x here, not a 20x. So I don't know if it's been corrected on your paper, but make sure you're just using a 2x. Now you have a square root and you have a negative x squared, so you know you're going to use arc sine. So I need to worry about underneath the radical, I need to complete the square. And if I factor out that negative, I end up in parentheses as x squared minus 2x. I've got to add something. And if I take my negative 2, divide it by 2, I get negative 1, square it, that's 1. But I'm really subtracting 1 there, so I need to add 1 on the outside. And of course I had this 3 outside the radical, so I'm going to bring that out in front of my integral expression. And underneath my radical, I'm going to have 1 minus, and then my x squared minus 2x plus 1 factors to be x minus 1 all squared, and a dx there. Now I use u sub with a u equal to x minus 1, which means my du is just dx. So that makes life easy. I don't have any constants to worry about here. So I can sub in. I get 1/3 out in front, the square root of 1 minus u squared du, which integrates to 1/3 arc sine of u plus c, and then finally I need to sub back in for my u to get my final answer of 1/3 arc sine of, instead of u, x minus 1, and of course I have a plus c. So let's do one more problem here, and this one I think is going to be arctan because I have no radical in the denominator and I have a positive x squared. So when I do this first one, or when I do this last one, I'm going to factor out a 3 out in front of the integral symbol. In fact, I'll take that 2 out of the numerator as well. I think that will help as we go. So my denominator becomes x squared plus 2x plus 5, and then of course a dx. So I've just factored this 2/3 out in front. Now I need to complete the square in the denominator. So x squared plus 2x plus something plus 5 over here minus something. So I need to know what number I'm adding here and subtracting here. Well, my b value is 2. 2 divided by 2 is 1. 1 squared is 1. So I'm adding a 1, subtracting a 1. So now in my denominator, for my integral, I have x plus 1 all squared plus 4 dx. Don't forget I have a 2/3 out in front here. And now I need to factor out this 4. So when I factor out a 4, I'm going to get 2 over 4 times 3 is 12. And then in my integral, my 4 became a 1, and my x plus 1 squared became an x plus 1 squared divided by 4, and of course I have a dx. Now I can simplify my 2 over 12 to be 1/6, and then in my denominator here, my x plus 1 squared over 4 goes to x plus 1 over 2, all squared, plus 1 dx. And now it's time to do u substitution. Finally, we get to the point where we get to do u sub with our u value of x plus 1 over 2 du equals 1/2 dx. And I need to multiply by 2 here to isolate the dx. So the 2 will come out in front. So 2 over 6 is 1/3 integral of 1 over u squared plus 1 du. Well, 1 over u squared plus 1 is going to integrate to arctan of u. So I'm almost done with this problem now. I need a plus c. And then I resub in for my u. So I have a final answer of arctan 1/3 times arctan of x plus 1 over 2 plus c. Oops, that's supposed to be a plus c there.